the elevator left, and then the washrooms are there. We do ask your permission to take photos. We'd like to, capture our community on our website periodically. So if you're okay with that, if not, we'll just, if you see us get up, just move to the side. Thanks to our sponsors, improving here is One Superheroes Academy and ACODIS. Our organizers, Brock, not here tonight, Gary, who went and got more pizza, Thor and Dan are online, and myself, Lisa. We have a new organizer, Tosin, she's not with us tonight, but she'll be joining us next month. And thank you again for attending. Any community announcements or job opportunities that anyone has? Jonathan.
I've got one. My name is Jonathan Hyde, and I'm one of the volunteers of Agile Open Canada, and we're a 2-day open space conference. We're running that at the end of May this year. You can check out our website, agileopen.ca. It's got more information on it. It's a 2-day conference for $130, thanks to our gracious sponsors who provide this, and you get to go to Banff for a couple of days on a Monday and Tuesday. It's a great opportunity to meet a lot of people from the local area in Western Canada who are Agile practitioners, Agile coaches, and have a bunch of focused conversations. We have 9 separate focused conversations throughout those 2 days on whatever you want to talk about. So the attendees drive the agenda. You can pick the topics you want to talk about, and it's a really good opportunity to meet people. So agileopen.ca, check it out and join us if you can. We have limited 60 spaces, and we've sold more than half of that right now. So there's still some space left. Thanks.
Any other announcements in the room? Online? I'm going to close that.
Oh, yeah.
That.
Cool.
Chats. Agile, there you go. Agile Open. All right. Over to you, Chris. I'll let you introduce yourself and your talk, and
cool.
I will step on.
Awesome. And I just want to know for the folks online, if I'm talking.
Oh, sorry, sir, you are muted.
I was just asking if you could hear me.
We could hear you, and then for a moment we didn't, but you sound pretty good to me.
The microphone is that bar up top, so
Okay.
it'll pick up. Yeah, Don's giving you the hands.
Okay, so cool. I'm not a quiet person, so I didn't think it would be a problem, but awesome. Thanks, everyone. My name's Chris Edwards, as you can probably figure out from the slide already. I'm one of the tech leads and team leads at Phillip Fleet. We're based here in Calgary, but our team's located all over Canada. Some of the team members are in the room. Put your hands up. I'm not going to pick on you too much. Your job's to heckle me, not the other way around. So just to get started, technology. I love technology. There we go. I want to get to know you folks a little bit. So this is going to be a little interactive. This is also an excuse. There's going to be different parts of this presentation that are going to involve a little audience interaction on your phones. If you're bored and don't want to listen and you just want to play, it's an excuse because I won't know that you're ignoring me. So just get your phone out. There's a link at the top there, polev.com/Chris Edwards 2020. And I'm going to do it too. Folks that work with me, maybe don't vote because you're going to, I already know your answers. Should be up. Oh, we're getting votes. There we go. Okay, so the question here, and this is really the core of the presentation, we're talking about how and when we deploy to production. So the options here, schedule maintenance window. So if you're going to release to customers, are you doing this on some set aside time, maybe on a weekend when there's fewer people using your system? I put NA there. I'm guessing some of you are not actually building products and deploying products. Awesome. This is great. Okay, so kind of getting the picture. If this was like all zero downtime deployments, I would just kind of end the talk here because none of you are really actually going to learn anything, but this is great. Next one. Should have switched on your phones. This relates a little bit to maintenance deployments or, oh, we got a few that release daily to production. This is great. Yeah, so kind of a good distribution, weekly releases. The trends in the industry has been moving towards more frequent releases. I know that a few years ago, I was working in a place we released twice a year to production, and releasing daily seemed kind of ridiculous, but now this is becoming more and more regular. No, that's great. Awesome. All right, I'm so happy that the technology is working with us tonight. Okay, so maybe just a question from the audience. Who here's like tried to use some kind of product or service and gotten blocked to use it because there has been some kind of scheduled downtime or maintenance? Any examples? Aaron, you're nodding. I'm going to pick on you.
Banking app.
Yeah.
Yeah, the website was down.
The website was down?
Yeah.
Okay.
After 10 p.m. in Western Canada.
In Western Canada, of course, yes, because the only place that exists is Toronto. So yeah. The one that happened to me recently was I was trying to do my taxes, and my goal is to get the taxes out of the way as quick as possible because it's my least favorite thing to do. And of course, the CRA was down on the weekend. Now, unfortunately, I can't just pick a different CRA provider. So I'm forced to use it, but not a great experience if you're a customer. So talking a little bit about our product, Philip Fleet. So we're actually a distributed payments platform, and our core business is actually helping people put fuel in the tanks of their vehicles. So our customers are small and mid-sized businesses, and they're just trying to get their work done. So these are like plumbers, delivery drivers. One of our clients is a well-known house cleaning service that you would have heard of. So if they're gonna be standing at the pump and pull up our app and they're trying to pay and they're like, sorry, you got to wait 20 minutes to do this, that's not really going to work for them. So the way when I joined Philip in I think 2020, so it's been a little while, our product, we actually worked with 15 gas stations in Calgary. Our app only worked when the convenience store was open. So we were able to kind of get away with not interrupting any of our users by doing our deployments at 11 p.m. So this is actual footage of me. No, just kidding. So if you can kind of think of it, not a great experience as a person on the development team. We would kind of like a couple of us would log on at 10:50. We do a bunch of checks to make sure no one's really using the app still, so that we could do this safely. We would take down our system and get the deployment done. Usually took about 10 to 15 minutes for us, and then we would head off to sleep if nothing went wrong. Ted sometimes was on the call with us in case something went wrong to help us out, but yeah, so this is I think pretty common, and based off the poll I saw at the start, this is probably a lot of what you folks are experiencing. The ones that do schedule maintenance, like when are you doing them? Are you doing them during your regular working hours, or is this like a weekend activity? Anyone here?
3 to 4 a.m.
3 to 4 a.m.
Yeah.
Yeah, that's fun.
2 a.m. last night.
Yeah, last night. Okay.
Okay, well, thanks for showing up. We got one guy with a new kid and one guy who did a 2 a.m. deployment. I'm surprised my audience is awake right now. Okay, so this might be something you're a little more familiar with. Those who are not technical, here's a bit of a background on, like, this is typically how a scheduled maintenance is done. So this is like really basic 3-tiered architecture. So usually you've got some kind of database on the back end. For us, we have a Mongo database. This could be a relational database, SQL database, usually some kind of server running on it, and then some kind of front end. Our application's a mobile application, but this could be a website as well. So usually you start, the server gets brought down, that's the maintenance mode. You run your data migrations and then spin up your new server, everything goes hunky-dory, right? So I mentioned we used to do our deployments at 11 at night, and that worked when we had 15 stations in Calgary, and we only were dealing with we only were when the store was open, but we now have an application that works with 12,000 stations across Canada. And this is actual data from our system of when our users are using our system. So you can see like your fellow in the crowd here was talking about the 2 a.m. deployment, we could do that and limit the number of users that are impacted. But the ones that are impacted at 2 a.m. certainly aren't going to be very happy with us. One of our customers, I'll give you an example, is they're out in Eastern Canada, and their company repairs downed power lines. So their actual business ramps up during major storms, which you may have heard there's been a few of in Atlantic Canada this year. So if they're trying to get to their site, they're trying to get power back to people, and they're now once again standing at the gas station, and they've got a maintenance window with us. That's not really going to work. So part of why I'm sharing with this is kind of illustrating that the way our business used to be, it was actually fine to do a scheduled maintenance in the evening. The experience for developers wasn't fantastic, but it didn't impact our customers. But our business model actually is what drove us to have to invest in this technology change. Okay, so what is a zero downtime deployment? What does that actually look like? And the goal here is to have your customers completely uninterrupted service to your system. So we do it, and we're on a Heroku system in our specific system, but there's lots of environments that can do this. We actually start with the database migration, spins up the new server. Heroku has a 5-minute window here that allows the server to spin up. We often talk about the 5-minute window at work. So this is, if you hear me talking about that, this is what I'm talking about. So there's 5 minutes that allows the server to spin up. The load balancer now starts routing traffic to the new server. So there's never a point where there's not a server that can provide service to the front end. The old server kind of gets drained. And I say server, this could be servers, multiple servers if you've got some horizontal scaling. And then you kill the old server. Now all the traffic's routed through the new one, your deployment's done, and you move on with your day. So I don't want you to answer, but I just kind of think in your minds, what could go wrong with this process? Where might there be problems compared to the scheduled maintenance?
At the very first stage, when you migrate your database, your old application doesn't know about the new data.
That's right. Yeah, sometimes it's safe. If you're doing a non-breaking change, right? It's additive data. Okay. The new server knows about it, the old one doesn't. That could actually be a totally safe deployment. Right. Yeah. So I'll give you one example of where this burned us, and I had to apologize to Jackie because he's actually the one that made this change. But it was just such a great example that I had to use it. So this was in December of last year. We got a call. Our support team got a call from one of our customers, and their employees were completely dead on the water. They were unable to fuel. So this is like, for us, stopping someone from fueling is the worst possible outcome for our application. So this is the most simple view of how our application works. Basically, money goes into people's account, their fill-up account, and then drivers empty money out of their account at the gas station. The way it generally works is every night we do a direct deposit from their corporate account into our fill-up account to top them up. And then over the next day, people are fueling. So we kind of, the goal here is to keep their account at a level where they're never going to drop to zero. People will never be fueling. What happened was when we dug into it, why don't they have any money? It was actually about a week and a half earlier this stopped for this one fleet. So it wasn't systemic. If it was systemic, if no fleets were filling up, we probably would have heard about it like right that day. And our app isn't really like a core part of their business. Like people aren't in our app all the time watching what's happening, right? They're going about their day. They're using our app to get to their day, not to spend their day doing fueling, right? So they noticed when it stopped working. So we dug into it. This was a bit of an archaeology mission. What we found out is that day that they stopped getting these reloads, we added a new feature to the application. We gave people, and so I'm sorry, I'm picking on you, Jackie. We added the ability we gave them the ability to control when their accounts got topped up. So it's driven off of, I think there was like accountants, they didn't like, it was hard to reconcile if they do it every day, maybe they just want to do it once a week. And for some reason, this fleet had this set to no days of the week. Okay, why would that happen? We're like, okay, maybe they went into the application and turned them all off. Well, actually, we found like we actually made that impossible. Maybe there's some bug that the front end wasn't passing the right data. So we looked in the logs. They had never called our system to change this functionality. So we tried to reproduce it. We're like, okay, we've got, our system has extensive automated tests. Those all passed. It went through QA. We tried to get them to reproduce it. We even looked at the migration. So we were able to prove that if we ran the migration that added these reload days to everyone's accounts, and we ran it against production data from that, and like everything worked fine. What should have happened is they should have now had every day of the week turned on. But what we found out is that that fleet had some activity that was going on during that 5-minute window I was talking about. So one of their people was at the pump, tapping their card at the pump and filling their gas tanks at the same time that our server was being deployed. So these two things collided. So the actual outcome, the actual culprit of this was our database migration, but it was a database migration that when you're in a real production environment didn't work as you would expect. So actually, before we do that, I'm going to do a little bit of a coding demo.
So what was the fix?
What was the fix? So the fix was very quick. We were able to just quickly fix their account and make it so they reload daily. So that was just like a database patch. And I believe we did I think we like temporarily granted them some funds just to like get their people back moving. And then they started like topping up and reloading again, and then they're back. And hopefully we hadn't harmed the relationship with them. Yeah, good question.
How did you fix the migration from not running into the same problem the next time?
How do I not make this happen again?
Right.
Great question. That is a great segue into the coding demo. Any more questions though before I dive into that, or online?
Yes, I want to ask, were there other people that were affected? Did you look for other people that were affected by the same problem, or you believe that the only people who reported the problem were the ones that were affected?
No, that is a great question, and that's actually when we're on support. So we have a rotating support on our dev team. So every one of our developers takes part in that. And we have a bit of a triage process, and part of that is like impact analysis. So you're kind of like understanding like what is the actual thing that's happening, who's affected, who needs to be notified. And we were able to prove that this was the only fleet that this had happened to, which has actually helped in the investigation of understanding like what was special about this fleet. Were they doing something at the time? It allowed us to narrow down what happened. So no, that's a great question. Cool. Okay. So get your phones back out, please. And thank you. If you want, I guess, free country. This is the most amazing piece of software I've ever written. It's probably so simple, ChatGPT could have made it. I'm going to pull it up. Actually, I'm going to pull it up here as well. Actually, I'll leave this up for a moment just to give you all a chance to grab that URL. Some of you started pressing the button by now?
Yeah.
Yes. How's that? It's fun.
It's fun.
We demoed this at work and found out on average people hit it about 100 times before they get bored. All right, so I am going to leave this, and this is my local environment. So you can see I'm running it locally, and this is the one that's running on Heroku right now. Ooh, you guys are doing good. 560, 70, great. Okay, so we are gonna do the simplest code change that anyone's ever done in a code demo, which is why it's gonna go badly. So let's see what happens. Okay, so let me just give you a very quick walkthrough of this code. This is our database schema. So I said we have a Mongo schema. So this is a NoSQL database. This is the definition in Mongoose. This is our data transform layer. This is what the database looks like. I'll pull up the database. So this is my local one. You can see I've got a counter. If I refresh that, it says it's at 40. What we're going to do is a rename of this variable, and we're going to watch it fail. So we'll just rename it here. I will rename it. We'll rename where we save and load the data. So this is where I'm loading it. I'm poofing up a new counter in memory. We're pulling from new value when we do that. When I save it to the database, I'm going to save it to new value. And then I'm going to write a very simple migration. Rename value to new value. Right. Let's not worry about downscript. So we actually, when we build these, we don't worry about reverting database migrations. Our policy is generally to do roll forwards if we find a problem. So wait, actually, let me keep that example. Typing in front of people is very different from typing in German. Okay, so we're gonna update. If you're not familiar with the syntax, that's not super important. So we're gonna update all documents. There's only one document in this collection, and we are gonna rename counter.value to counter.newValue. Just double check counter new value. Okay, so there's my schema. I am going to run that against my local database. Cool. And I'll test it locally. Let's imagine I've got like automated tests against this. I don't. Oh, this demo is already going great. Oh, I didn't reboot my server. There we go. I actually just demoed the thing that went wrong. That's fine. Okay, so now I'm going to check this in and we're going to push it. Very simple code change. We'll say rename value to new value. And I'm going to make this Zoom screen go to the way. Hide floating panel. We'll push that. Okay, so over here, this is Heroku. Heroku is pulling directly from my Git repo that I've just pushed. It's from the master branch. And in a moment here, you should see it spin up. It's building the server. This should take about kind of 20 seconds, and then it'll deploy the change. So keep being my users. You can keep pressing the button. I'm doing zero downtime deployment here. Everything should go fine, right? Yes. Gary's having fun. Okay, it's deploying. The migration ran. Right. So. That's interesting. It's working. It shouldn't have worked. All right. Well. No, it still says value. Did my migration not run? Oh, that's my local one. That is interesting. I actually think what happened was we had a little concurrency collision. The database migration was running while one of you was hitting the button, which is another interesting thing that can happen. So I did. You guys are hitting it right now. And you can see what's happening here is the old code. Actually, let's just move on to the slides. This is the thing. Everything behaves differently in production than it does when you test it on your own.
You could just copy your migration, rerun it to demo again.
That's all right. We can, if we wait 5 minutes, it will actually stop working, and I'll just explain why in a second here. So what's actually happening right now, this is you guys at the top here. You're all hitting the old server. That's why the server in the database we saw, it still says value. So when you guys are hitting the button, it's incrementing the old value into the database. My migration ran, it replaced it, renamed it, but I think what happened was there was an active database request and the in-memory value saved and overwrote that before it finished. So that's actually a really different, interesting outcome that I didn't anticipate.
So basically anything could happen.
Anything, this is a great demo that I didn't expect.
Probably with relational databases, it wouldn't happen.
If that, so thank you, Mike. Mike just made a great point. If this was a relational database, this would have behaved very differently because the schema would not have matched. What would have happened? You would have gotten a crash probably. Yeah. So crash for 5 minutes. Your users can't use your app for 5 minutes, or data corruption. The trade-off. Engineering is about trade-offs. Okay, so I've already forgotten. One of you asked, how do you not do this? Remus, there you go. So what we're going to do is what we call the 3-step migration. This is an example of how to avoid this problem and make sure that basically your database is completely fine at all the steps and your users never experience any kind of outage. This is not the only way to do this. This is one example of how to do this. There was one situation where we had to migrate an array of objects out of a collection, out of a document into its own collection. And we worked out a 7-step process that we did over the course of a week because we release roughly every day. So I'm going to kind of walk you through how I would solve this specific, very simple rename. But there's patterns out there you can research, and if you're interested, I can walk you through some different ones that we've done. Maybe now is a good time to pause because I've just been talking a lot. Anyone have any just questions before I dive into the next phase of this?
The counter changed. Counter was reset.
Your 5-minute window ended.
Yeah.
The new code is now executing. Still working. Did it reset down to 0?
Yeah.
Ooh. All right, how do I get out of the presentation? There we go. I love technology. There we go. Oh, although you're still hitting it. Let's see. We hit 100 per person yet? Awesome. I had a fallback plan if the deployment to Heroku failed, so I'm glad that part's working. Okay, so we're going to actually do 3 different deployments now. And each one will have a fairly small incremental change, and it will continue working at every phase. So the first one we're going to do is our server is, so we're not going to do any database migrations. Our server is actually going to recognize both schemas as valid. So it will save to both names of the, so it will save to value and to new value, and it will be able to read from value and new value. So it will be able to basically handle 2 database schemas. So what we're going to have to do is our schema right now says new value. Is that right? So if I were to open up our database and query it, this is the production database. It says new value. You guys are at 730. So we'll rename it to newer value. Okay, so code saves to both places. So this is our 2doc. This is the thing that's saying what it's going to save to. So we'll save to new value and newer value. Cool. And we will read from both places. So what we'll do is a little bit of a fallback. We'll kind of say if new value doesn't exist, we'll fall back and read from newer value. And the last thing we need to do is update our schema. So we'll never actually have a database that has both values in it. But what we should have is for sure at least one of the two values will exist. All right, so this time I'm going to restart my server. And we're not going to do any data migrations in this release. So in theory, if I test my local, okay, it's working. So let's check that in. Server now writes to newer value and can also read from it. Boom. All right. If you're bored, hit the button. Any questions? Just showed them out. This is kind of one of these stand and wait parts of the presentation.
So how long do you keep it like this? Duplicate.
Good question. So we generally release daily at our office. When we do these, we may do multiple deployments back to back just to get it out of the way. There's a bit of a mental load of having like a database migration live over multiple days. Like if we were to do 3 migrations over 3 days, well, now you need to track that you're doing that. And now, okay, I'm doing step 2. I have to like boot my brain back up into, well, what was that? And my likelihood of making a mistake goes up. So it's an interesting question because it ties into release frequency. If you're doing a release every week, this is going to be much harder to do because now you have to do a 3-stage migration over weeks while you've got other code development going on. Like, I don't want to be thinking about this. I want to like finish this and move on with my life. Yeah. Okay, it's deployed. Is it working? You folks were busy. Okay. So we're now back to, we're still running the old code though. So when the 5-minute window is up, I keep saying 5-minute window. This is totally a Heroku thing. Heroku doesn't let us configure this. You saw the server boots up like very quickly. If anyone knows anyone at Heroku that would like allow me to make this configurable, that would be fantastic. So sometimes when we do these deployments, there's like, okay, sit and wait for the new server to spin up. That's fine. I'm not going to make you do that. I planned for this. Okay, so while that's deploying, I kind of want to talk about the other things that we do at Phillip that enable this to work. Remus, you already kind of led into like our continuous deployment practices. So we release daily. Releasing daily, we do that for many reasons, but this is one of them. Releasing frequently can only really be done if you have high confidence in quality. So one of the practices that our entire team does is called test-driven development. Show of hands, like who here would you say you do test-driven development in your job? Yeah, awesome. That's hard. What does it say? I can't read that. Oh, raised hand. Oh, okay. Go ahead. Oh, she does. I see. I think I'm working on it. All right.
Well, you could ask Sarah, do you have a question?
No, I was answering who is using test-driven development.
I got. Yeah, so for those who don't know, test-driven development is it's a practice where we're writing tests all day as we're coding. So we do what's called red, green refactor. We write the test first. We watch them. We write a test. We watch it fail. We write the minimal amount of code that to watch that to get that test to pass, and then we will do continuous refactoring. Something we do that's a little bit different than other places that I've worked at, other you folks here may be doing it, is we don't do a lot of unit testing. So we actually test at more of a functional level. So in our system, we actually test right below where the API calls are. We're testing, our system under test is basically our server. What our tests look like they look very close to the system, the behavior of our users. They read like what our users are doing. So I'll acknowledge there is a downside to this kind of testing is these tests take longer to run than unit tests. We have a database, it's an in-memory database when we run them, but it's not that long. I think, Philip, folks, what is it, about three minutes to run the full test suite right now?
2,200 tests.
2,200 tests. Yeah. What it brings though is an extremely high level of confidence that we haven't broken anything. We're testing actual behavior of our system. And the other one is refactoring our code is very, very easy. I very rarely have to modify tests when I'm doing refactoring. Unit tests test a lot of the implementation of your system. And for us, the definition of quality of our code is how easy is it to change our code? And this test suite is the thing that enables that. And we would not be able to release at the frequency we do without that confidence. I think like a full regression of our system right now, like when we get the whole team swarm on it, I think we usually do it in a day or two. So obviously you couldn't really release daily if you were gonna do like a full manual regression of your system. So we do continuous integration. Also, like another kind of way of thinking about this is like trunk-based development. So we don't use any feature branches. Every commit goes right into master and gets pushed right into master. They don't deploy directly to production. That's part of our daily release process, but the entire team is committing all day. I think, it would be normal for someone to do 10 to 20 commits in a day while they're working. So we talked about frequent releases. They're not as frequent as other places. There are some like downsides to us releasing more frequently. If we were to release our mobile application all the time, it causes like an update in our users. So if every time they open our app all the time, it's doing updates while they're trying to do things, it would actually be disruptive. So this is a bit of a trade-off that we've made. It's not a good sound. We do a ton of high frequency collaboration. So constant transfer of knowledge by working directly with each other, either in pairs or in mobs. And then you're also getting constant feedback. So we have a continuous code review process. Someone sitting with you giving you feedback right away. We use feature toggles. I may build something and it's only on in my local environment or in our QA environment, but doesn't actually, there's entire pieces of our code that just don't even get activated in production. Or we use cohorts. So it might be that our internal users, so as this is what we call dog fooding, eating your own dog food. We'll have functionality that's only turned on for us while we're building it and developing it and making sure that it's high quality. So it's a type of branching. We're branching our code paths, but we're doing it inside of the same trunk.
And something important about toggles and cohorts there is they shouldn't live very long, or you end up with all kinds of very complicated test paths.
That's right. Yep. Yep. Yeah, and it's so like, I'm trying to think. Let's use the example of the reload days. We may have, cohorted that for our internal fleet so that we can make sure it's working really smoothly before we turn it on for everyone. And then we kill the cohort once it goes live to everyone because it doesn't need to be, we don't need two code paths to our application anymore. That's a great point, John.
Your toggles go into the main code base.
Yes, everything goes right into
Released
master
every day.
and gets released every day. So imagine if you're releasing like the extreme, like if you're releasing monthly or every 3 months, every bug you introduce into that, you find out in a giant, massive chunk of code changes that get deployed on one day. And a bunch of them were stuff I built 3 months ago and I have no memory of. We deploy things. One of the things I didn't put on here is the amount of monitoring and logging and alerting we do. which is another thing that really ties into this. So when we put something out, not everything we put out is perfect. Sometimes it has problems. We get alerted very quickly. We address it very quickly. And the context, it's already in the context of our development team. So we're usually able to fix it very quickly. So ideally the impact is low. Ideally it's us impacted and not our users. So the example I gave earlier was probably one of the worst cases where we took down an entire one of our clients' ability to fuel, which is not great. But those are actually fairly rare. I'm sure Ted can share numbers that he's reports on our uptime. And
2 in the last year, twice we've stopped somebody from fueling in the last year.
yeah, only.
That's pretty low.
What's that?
That's pretty good.
I have a great team, lucky to have guys that are so dedicated to all.
Yeah, and this is the last piece is we follow the you build it, you run it. So I talked earlier about our entire team being on a rotating support. We don't have a separate operations team. So the definition of DevOps often is we renamed the operations team the DevOps team. That's not how we do it. So we are all responsible for the quality of what we build all the way until it's in the hands of our users. And that creates a feedback cycle because when we introduce problems into production, we're the ones feeling the pain. We're the ones that have to fix it. We're the ones that have to support it if the system goes down on the weekend. It creates an incentive to create quality, but it also creates a much faster learning. So increases our practices, improving how we log things and alert things so that we can find out about them and debug them and find out how our system's operating. We invest continually in that. Okay, before we go back to the demo, any more questions kind of about this?
So you do a lot of extra logging. Do you think you would have found the fleet issue that you had without your extensive logging, or is it like, did you make changes to your logging?
Yeah, this one's interesting because from an error perspective, nothing went wrong. Nothing incorrect from there were no 500s returned to the user. It's nothing like there were no signals.
No fire.
Right? There's no fire. The fire though was this fleet was running out of money. So what we're kind of looking at here is abnormal business outcomes, which I don't know that we actually necessarily have great visibility into right now. And I think that's maybe actually something that we would invest in the future is, oh, maybe we get alerted if a fleet starts dropping down to low levels. There's a bit of interpretation there because maybe that's because they turned it off and they actually don't have the cash flow. Of course, that might be useful to an account manager. Maybe they want to give them a call. Are you guys interested in credit? Can we offer you something else? Right. So I think we would probably handle that in a different way than necessarily it being the technical support team. But if it was, okay, some kind of business outcome here is not great, that might have led to us finding out about this earlier. But I actually don't think we have a solution to detecting this problem right now.
Yeah. So you have a lot of logging, but not for this.
No, and a lot of it is we can see if something is breaking, users having a problem, the user tried to do something, got an error. The user did something and our worker process failed. So the user doesn't know it's happening, but we can detect very quickly. And then when we know something's wrong, are we able to get visibility into how our system's functioning and actually know why it's not working? That's been the areas that we've been investing in. So it's kind of like that observability side. Can we understand the actual internals of our system while it's running? We definitely do not have it all figured out either.
No.
Yeah. Great questions. How are we doing for time? All right. See if I can get 2 more deployments done in 10 minutes. Okay, I'm going to move on. How's our app doing? Is it functioning? We're up to holy. I guess if you're just sitting there listening, you can just keep. All right. So Did anyone see any I mean, if you guys are using it, have you guys seen any disruption in it while you've been using it? It's been working great. So in theory, if I go into the database, I see a newer value. Oh, this was happening earlier. I don't know why I had to reopen it. Oh, that's interesting. Oh, we're saving to both places. That's exactly what we expected. Step 2. Migrate the data, but leave the old data there. So we did a rename last time. So what we're going to do now is we're actually going to do a copy. So this is a little harder to see in the example because we only have one document, but let's imagine I had like 10,000 documents in here and only some of them had been modified and hit during this time. You would have a whole bunch of documents that still had the old value. So what you would kind of expect is we'd see new value copied into newer value on all of the documents. So every document in our database, after this migration is going to have both values. So let's do that. npm run migrate create copy new value to newer value. Boom. Zoom bar keeps reappearing. I want the AI that knows when I want that to go away and just have it happen without me having to do it. Counters. We want to modify the whole collection and we want to do this as an aggregation pipeline. Don't worry, you don't need to know what that is. We're going to set counter.newer value to the value that is currently in counter.new value. All right. Let's look at my local database, which currently has both. We're copying 2 newer values. So I'm just to double check that my migration works, we'll delete new value on my local database. We'll run the migration. Migration did bad things. Okay, this is why you test your migrations. If this doesn't work, I will just move on with my life.
Do you have new and newer in the right order in your migration?
Nope. Oh, I'm setting newer to new. Okay. Yeah. Okay, well, that's fine. Let's just imagine, we're getting short on time anyway. Let's just imagine that worked lovely and we'll just continue on with the presentation. So the goal of these steps is that at every point in time, both of the servers that can be live and receiving data during each deployment can interact with the database that's currently there, right? So V2 server had to be able to interact with the old database and this database, and V3 needs to be able to handle this database and the one that's coming after it. So our new code will stop writing to the old schema and will only read from the new schema. So we'll only write and read from newer value. So at this point, our code doesn't know about the old, what the old schema looks like anymore, but we've still got like this old lingering data hanging around. And the last migration is just to clean up the data that's just kind of like cruft data that nothing in our systems really cares about anymore. And then we're done. So this is like 3 fairly small, simple steps. And after you do it a few times, apparently not, as I've demonstrated, I'm like, oh, it's very rote, and you can just do it without thinking. No, you still have to be careful, obviously, and test it and make sure every step works. Okay, so I'm gonna actually play my slideshow. This I was gonna show you while that second stage migration was running. Just kind of want to talk about like where we are in our journey, why we're doing what we're doing today and why it was different before. So our product has actually been live since September of 2021. October 2021. Thank you, Ted. So before we launched, we were developing this. We were actually launching to production. We were consuming it. We were out pumping gas, but we had no customers actively using the software. We would actually do like database resets like we're not breaking anyone. We don't actually have to worry about database migrations. When we launched, there's very, very few people using our system. So the odds of someone doing something during the 5-minute window were remotely small, and we could usually like pay attention and fix it up if it came up. So the repairs were quite easy. The likelihood of negatively impacting someone were low, so we may not do it. Today, we process, I think, like millions of liters of gas gets pumped using our application every year. So the odds of activity, I think, during any point in the day, maybe not in the evening, but we can't predict which 5 minutes that are safe. The likelihood of something colliding with our migration right now today is very high. And then as we grow, it's just gonna, there's just gonna be constant traffic through the system. So our attention to quality on these migrations is just gonna keep going up and up. I think this is important because this practice I'm talking about, doing these zero downtime deployments, doing these migrations, I don't think it actually matters for every company. I don't think it's important for every use case or every customer base, but it's incredibly important to us because we're dealing with money movement. The correctness of data is extremely right, balances, ledgers, and our product is crucial to people doing their job. So if our product breaks, people's businesses stop functioning. So uptime and correctness are just like extremely vital. Oh, apparently clicking whatever I just clicked makes the Zoom bar come back. Okay, so we talked about this. We did a demo. 2 minutes. Okay, this is my lightning round. Really quickly, do we always do this?
No.
No. You're good. Okay. No, we don't always do this 3-step migration. We do a bit of an analysis every day. If you check in a migration, we have some automation that gets written. It dumps it right into our Trello board that there's this migration. We have a release risk conversation, and part of it we discuss essentially like 5-minute window risk of every migration. Additions of data are pretty safe. Migrations into pieces of our database that are not as like high impact, we might not worry about it. We might just pay close attention while it's being released, and if anything gets broken, we'll just manually fix it. That's cheaper for us than doing, oh, we're gonna be careful and do these 3 steps and do 3 deployments. That's more expensive than just like watching a deployment for 5 minutes and seeing if anything went wrong. Okay, so yes, go ahead. It's a lightning round, no questions. No, go ahead.
Oh, sorry, no, I didn't realize.
No.
If Heroku didn't have a 5-minute window, it was closer to a hot swap.
The risk would be way lower.
The risk would be way lower. So my question is, what percentage of the ones you do in 3 steps today would you still do?
It would be the ones that have high risk impact to balances, ledgers, and those types of things. So it would probably be lower. But as our scale ramps, it's a risk mitigation strategy, right? What's the probability that something bad's going to happen during that window is essentially what we're doing, and we're doing it's a trade-off with our time. So yeah, no, it's a good question. Okay, so this is a phrase that gets said, just be more careful when things go bad. I think this is a mantra I learned from Ted. This is not a solution. Being careful. This is why we have safety nets. This is why we do testing. This is why we improve feedback loops in our systems so that we can catch problems quickly, because we're humans and we make mistakes. Doing this thing safely and having a safety net is hard. And it's a thing that we don't currently have a safety net on. And we have some ideas of how to do that. Some of them are around early detection. So can we write a script around our migration that runs at the end of that 5 minutes and validates if anything went wrong? So now I don't have to remember to do it. I don't have to like be paying attention when Jackie's doing the deployment and I'm off working with someone over here while my migration's running. I really don't want to have to like, okay, the whole team stop, we're doing the migration, everyone, or we're doing the deployment, everyone watch. So we've been thinking about ways of automating this so that it's automatic. And automatic means I don't have to remember to do it, which means human error gets removed from the equation. So this is something that I would say that we aren't doing well yet, and we want to keep working on. We have invested a ton in training and teaching and developing everyone's on the team's ability to recognize when this is a risk. How do I analyze the risk? How do I know that this is going to be a problem? And also, how do I safely do these things? So this is the other side of the equation, is us investing in the competencies and the skills of everyone on our team so that we can all do this safely, has been the other part of the equation. What's next? I talked about what's next. Okay, let's skip that slide. Any questions? All right.
Any questions online?
Earlier, you said that we decide which process to deploy. When you say we, do you have a separate cab group or a tag group or something, or is it up to the developer who's deploying?
Yeah, it is up to the development team. We and because our development team owns every aspect of our release process, we do make these decisions as a team. It's part of our daily stand-up. We have a conversation about our release process. We talk about migrations going out. We talk about high impact changes that are being made, and do we need to pay a little bit close attention? Like, do our standard quality checks cover it? But yeah, it is the developers, the entire development team that makes that decision together. Yeah, great question.
Yeah, it's not about the migration, but monitoring process. You're saying that you have some alert systems when things go wrong. So I was curious whether you are using some monitoring system like Elasticsearch ELK stack, or you are also using some alert mechanism like SNMP protocols or something like that.
Yeah, what we have is very low on the technical side. It is the 95% of them are alerts against our logging that feed into a Slack channel. Okay, that we get on our phones. Okay, so mine's been off. Have we had any while we've been sitting here, Ted? No. Okay. And James, I'm actually on support today. James was one of our other tech leads, took over while I'm doing this presentation. So, but in theory, I would get them directly to my phone, and they're just like, actually here. I'm in Heroku right now. Let's look at it. So, boom, Paper Trail is the add-on into Heroku. You know, let's say I want to be alerted if there is a status like a 503 error or something. I'll go create an alert. Create alert, search, not create alert. Server blew up. And we make some pretty refined, specific things we're looking for. We have a standardized error handling system on our back end. So if anything really severe happens, we have specific things that we're looking for. And then the person that's on support is doing that triaging. They'll go look at the logs. They'll see what specifically, there's usually like a stack trace and some other indicators. What was the user doing? What's their user ID, fleet ID? We can usually see some parameters that they were operating on. We might have some more detailed logging around that specific activity. Yeah, but in here, create alert. Send it to Slack. There we go. That's it. It's not, well, we're not super fancy.
Okay, that's good.
Yeah. Yeah, I think the investment is in what type of information do we want to emit from our system, and not just through the logs. We also use some structured logging in our database. We'll do things like store requests that come into our system externally. We'll store a high impact area of our system is obviously money movement. So we interact with the external system that handles the visa payments. So anything that goes in and out of that system, we're logging that directly into our database so that it's really easy for whoever's on to support to reconstruct what happened over time. Debugging is like detective work, right? So the more breadcrumbs you leave yourself, the easier it is.
And I'd say somewhere between 40 and 50% of the time, the team is able to fix the bug before the person has called us.
Yeah.
So they'll be on the phone giving us a call, and it'll be, yeah, we saw that, and it's solved.
Yeah. If we can let our customer support team know about the problems before our customers do, like that is absolutely a goal. Yeah. We aren't always able to fix them, but like I think our response time on fixing production issues is like vast majority of the time, it's like sub 10 minutes. So.
Any other questions online? Just checking. All right.
Thank you.
Thank you.
Thank you.
Jonathan online, do you have a question?
No, I was just saying thanks.
All right, perfect.
Cool.
So hand up. Well, that's clapping.
Oh, that's clapping.
Yeah.
Technology, right? So thank you, Chris. This was extremely interesting, and you drew a fairly large crowd. So
Half of them
Thank-
know me.
yeah, well, thank you. And take a slice of pizza on your way out.
Pizza box.
So next month, May 11th, we are announcing our relaunch of Calgary Agile. It was, you may have known it as Calgary Agile Methods User Group. So we're going to have some giveaways and a couple of different speakers. We'd love for all of you to come and bring a friend. We'll have pizza on time this time and some drinks and just celebrate the relaunch. So I'm extending a personal invite to all of you and all of you online, and hope you can come out in person for that one. Dan, do you have a QR code on feedback, or we're not doing that today? There we go. Let's chat so it works. So yeah, if you can fill in a couple questions, provide some feedback to us, we'd appreciate that. And with that, we will close the session tonight. Thanks, everyone.
Thanks, Chris. It was awesome.
20,000?
22,000?
No. It should be.
Thanks, Chris.
Oh, thank you.
Good night, everybody.
Oh, Don, good to see you.
Thank you all. Bye.